In this video, we're going to graph a couple of ellipses where the equation looks something like this. And this is not the form we've been graphing. Uh, this is not the form we've been using when graphing ellipses. And so we're going to need to rewrite it so that we can identify those values a and b and h and k for the center. And we're going to do that by completing the square. And so the first thing we're going to want to do is subtract the constant term over to the other side. We know that eventually that right side is going to be 1, but that's the last thing we're going to worry about. On the left side, we're going to get the x squared and the x terms together, so I'm just going to change the order of the terms here, and then I'm going to put the y squared and the y terms together. And then we want to look at the squared terms, and if there's a coefficient that's not 1, we want to factor that from that part of the equation. So x squared has a coefficient of 1, so we don't have to touch the x terms. But y squared has a coefficient of 4, so we're going to factor that from the terms that have y. So in the parentheses we'll have y squared plus 6y. And now we can add something to both sides that makes it possible to factor these, because remember we want to have x minus something squared and y minus something squared as part of our formula. So we've done completing the square back when we were talking about quadratics. We said that if these are your terms that you're looking at, so a is the coefficient on the squared term, b is the coefficient on the linear term. Then we said we need to add b over 2a squared in order to make this factor as x minus something squared. So we're going to be adding something here that makes a trinomial that we can factor with the x terms, and then we're going to be adding something inside the parentheses here so that we have a trinomial there as well. So for the x part, b is 10 and a is 1. This gets a little confusing with ellipses because these are not the values a and b in the ellipse equation yet. This is a and b from when we talked about quadratics and completing the square. So b is 10 and a is 1. So here we need to add 10 over 1 squared to both sides. Sorry, 10 over 2 times 1, right? It's b over 2a. 10 over 2 times 1 and then square that. So 10 over 2 is 5. So we're adding 25 here so that the x part will factor nicely. If we add that to the left side of the equation, we have to add it to the right side as well. And then here we have for the y part, b is 6, that's the coefficient on the linear term, and then the coefficient on the squared term is 1. We're just looking inside the parentheses for this. So 6 over 2 times 1 squared is going to be 3 squared, which is 9. Now here's where we need to be careful. We need a plus 9 inside the parentheses there. But we're adding 9 inside the parentheses, which means then that 9 is going to be multiplied by 4. So really we're adding 9 times 4 to the left side of the equation. And because of that, on the right side of the equation, we need to add 9 times 4. If that's not super clear, maybe it'll help if I write it out this way. So we're adding 25 there. So that's means we add 25 to the right side, and then we're adding 9 in here, and that 9 gets multiplied by 4, which is 36. So we have to add 36 to the right side because we didn't add 9 to the left side. We added 9 inside the parentheses, and everything in the parentheses is getting multiplied by 4. I think that's like the trickiest thing when you have that coefficient up front. Okay, now why are we doing this? Because x squared plus 10x plus 25 factors nicely. You can do your factoring technique off to the side if you like. This is going to be x plus 5 squared because 5 times 5 is 25 and 5 plus 5 is 10, and the middle term was positive, so it's going to be x plus 5, not x minus 5. All right, and then we're going to keep that 4 out front, and we're going to factor what's inside here. That would factor as y plus 3 times y plus 3, which is y plus 3 squared. Again, 3 squared is 9, 3 plus 3 is 6. It's a plus because that middle term was positive. And then on the right side, from our negative 45 plus 25 plus 36, we have 16. And then this is where we were at in the previous video, where we said we need to get the right side to be 1. And so to do that, we're going to divide by whatever is there. That way it'll be 1. And if we divide that by 16, we have to divide both terms. We have to divide both terms on the left side by 16 as well. And 4 over 16 is the same as 1 over 4. And so this is what our equation looks like. And so now we can find the values a and b as we identified them in our ellipse equation. So a squared is 16. Since 16 is larger than 4, 16 is a squared, so a is 4. And b squared is 4, so b is 2. And we can identify our center from the numerators. The formula has subtraction. We have addition here, so we're going to have negative coordinates for the center. So negative 5, negative 3. Always plot the center first. So negative 5, negative 3. We're going 4 units from the center in the x direction, so 4 units left and 4 units right to plot our vertices. And then we'll go 2 units in the y direction, so 2 units up from the center and 2 units down from the center. C squared is a squared minus b squared. So c squared is 12. C is the square root of 12, which is about 3.5. So we're going about 3.5 units from the center to plot each focus, and we're going in the long direction always to plot each focus. So 1, 2, 3.5. They're going to be pretty close to the vertices. 2, 3.5. So negative 5 plus the square root of 12 for one of the x coordinates, and negative 5 minus the square root of 12 for the other x coordinate. All right, let's do another example where we need to complete the square. So we're going to start by getting the constant term out of the way. And we're going to reorder the terms so the x terms are together and the y terms are together. Now this time both of the squared terms have a coefficient that's not 1. So since we have 4x squared, we're going to factor a 4 just from the x terms, not any of the other ones. So we're going to have x squared minus 6x there. And then since we have 9y squared, we're going to factor a 9 from the y terms. And we'll have y squared plus 4y. All right, and then we need to add something inside each set of parentheses. And so half of 6 is 3, 3 squared is 9. So we need to add 9 here. And we didn't really add 9 to the left side, we added 9 inside here, and then it gets multiplied by 4. So we need to add 36 there to the right side. And then here, half of 4 is 2, 2 squared is 4. So we need to add 4 inside the parentheses. But again, that 4 is getting multiplied by the 9 out front, so we need to add 36 to the right side. The linear term here is negative, so we're going to have subtraction this time. Again, you can just off to the side factor this with your usual factoring techniques. But since 3 squared is 9 and 3 plus 3 is 6, it's going to factor as x minus 3 squared. Here we have a positive middle term, so it's going to be y plus something. 2 squared is 4, and 2 plus 2 is 4. And on the right side we have 36. For ellipses, you should always have a positive number on the right. So if you don't, go back and check things. Now that we have gotten this far, we can divide by 36 to get that right side to be 1. So it matches our ellipse equation formula. And we're going to divide by 36 on the left as well. So if x minus 3 squared over 9 plus y plus 2 squared over 4. And we have x minus h here, and we have x minus 3 for this one. So h is 3, and then y minus k, so k is negative 2. So the center's at 3, negative 2. And the larger number is under x, so it's longer in the horizontal direction. A squared is 9, a is 3, and then b squared is 4, so b is 2. So the center is at 3, negative 2. 3 units in the x direction from the center to plot our vertices. And 2 units in the y direction. So up 2 and down 2 from the center. C squared is a squared minus b squared. So c is the square root of 5, which is about 2.2. So we're going 2.2 units from the center in the long direction. So one focus right about there and one right about there. So 3 plus the square root of 5, comma negative 2, and 3 minus the square root of 5, comma negative 2.